Hello everyone, today I will talk about something of machine learning and make an introduction of linear regression algorithm. First, I will make a simple self-introduction. My name is Wang Jing, and I'm engineering from IBM CDL SPSS algorithm team, and focus on big data machine learning algorithms for almost 3 years. Our team's work is to research and develop the latest algorithm and deliver the stable production to customer. Look at the agenda today. First, I will talk about what is machine learning. I think it's the most important question for you today. The second is data analysis basic process. It will teach you how to use the algorithm to solve the problems. The third part is the big data algorithm introduction, and I will talk about linear engine algorithm at the important point. Okay, what is machine learning? Before I introduce machine learning, first of all, what is data science? Data science is based on data with the help of theories and tools to solve customer business problems. Data science is an interdisciplinary subject. Let's take a look at the graph below. This graph clearly shows the scope of data science in software engineering, domain knowledge, and mathematics statistics. We look at this graph clockwise. Software engineering combined with the domain knowledge, we call it the traditional software. Traditional software such as financial processing system, ticketing sales system. This characteristic is to deal with data without artificial attendance and make people work more efficient. With the domain knowledge combining the mathematics statistics knowledge, this is what we call traditional research. Without the computer, we can do some theoretical research to solve the problem of industry, but because of the very large amount of calculation, it's not possible to do it without computer. When statistics and software engineering are combined, this is what we call machine learning. So machine learning is a discipline that studies how to use machines to simulate human learning activities. It is simply based on data, exploration and learning, and constructing algorithms to make predictions. So the three parts compose the data science. This is at the beginning of 2016. The survey for data scientists to see which algorithm to use more and more popular. Below table is the top 10 algorithm. The first is the regression algorithm. The regression algorithm focuses on the problem of relationship between variables. There is two kinds for this algorithm. One is called regression. Another one is classification. The following algorithm decision tree, KNN, nearest neighbor, random forest are all used for categories classification. With visualization and statistics are methods, not algorithms. These two methods are the most commonly used method by data scientists. PCA, which is the principal component analysis. It is actually a dimensionality reduction algorithm. Some problems are difficult to analyze in 3 dimensions, but when it reduces 1 dimension, the problems may be good to solve and easy to solve. Time series is to address the issue of the another categorical, such as data has a field which is according to the time sequence. Finally, text meaning. Text meaning is used to extracting useful information from massive text, many data, and then constructing the model with algorithm to make predictions. It needs a lot of work in the early data extraction and arrangement. The most popular application is advertisement blocker and news feeds. Look at this page. Second part, we will introduce data analysis basic process. This is the life cycle of a data analysis process. The left is the model deployment, and the one on the right is the model analysis process. Model analysis based on user historical data, then goes through business understanding, data explore, data preparation, data analysis, and result verification. Then occur new data. This form a closed loop in analysis process. The left is the model deployment process. From the publish of the model, continuous improvement go by test and application integration, then deployed to users' business scenario. Then it will generate shared insights. It will used to help users for decision analysis. Algorithm almost exists in everywhere in this process. The entire process for data analysis is split to training and testing process. When a user gets a historical data, the data will be split to training set and testing set. First, one record in training data includes predictors and target. In the graphs look like one y and y. The amount of records will go through the training process. With the help of a copart algorithm, the training process will get the built model. The records from the testing set will use this model to do scoring and make a prediction for the test records. The observed target is y, and the scoring target is y. So the model accuracy is 66%. It is not a good model for this scenario, but it's just an example. Okay, next, I will introduce how to use the process in our product IBM SPSS modeler. The stream also has two branches. The upper one is the training branch, which is used to create the model, and the down part is the scoring branch. It is used to predict and evaluate the model. Look at the training branch at first. The first one node is used to read data, and then set the field type for each field. It could be continuous or nominal. Then the important features can filter the field. Drop the not useful field. Missing value imputing is used to fill the missing value in one record with mean value or mode value. It just depends on the categorical or continuous. Then the data can be put in the linear model. The scoring branch is same as the training branch. The only different point is the data. One is testing data and another one is the training data. After same process, testing data will do scoring with the model from the training branch. The result can get the predictor values and the model evaluation of this model. This is a simple use in IBM's SPS modeler application. The third part is the most important today. I will introduce the basic algorithm by algorithm categories and introduce the linear regression algorithm. First, I will introduce the big data. What is the big data? The concept of big data has been around for a long time, but it is not easy to define. In fact, big data it can be expressed in four words: volume, velocity, variety, and veracity. Volume is a very large index. The data size is not GB, it is TB or PB. For example, the transaction data of a bank in one day. The transaction volume is hundreds of thousands. One precise call record in one day. It cannot imagine such data, how big data it is. Second V refers to data generate fast. IBM and GE has some business. GE, one of the most famous is the aircraft engines. Aircraft engines, there are thousands of sensors. Each sensor produces data at a speed of 0.3 seconds, so we can see how fast the data produces. The third way is a very large number of storage methods. For example, when to do a questionnaire, one way is to store the solver result in the form of paper. This is always the most traditional way. There is another way for a link, which is a questionnaire on the phone or computer, so that the data exists in the database. And many apps support the data to be translated into CSV or TXT format. The third way is to make phone call to do the questionnaire, which is to store it in audio, so there are a variety of ways to store data. Finally, the way is referred to the data as the data is bigger and bigger, produce faster and faster. The collection data will find some error or may appear some incomplete data. So this is big data for V. I think big data's concept is not it's difficult to define, but with 4V we can find what is really big data. So I will introduce the big data algorithm by category. Big data algorithm, I will introduce the by category. The first one is data exploration. What is data exploration? It is used to analyze and describe the data. The big data make us not easy to describe what the data really looks like. So we can describe one field with mean or mode and something like variance, or describe two fields with correlation rate. Data preparation is to pre-deal with data because garbage in and garbage out. If data has missing and we need to input it first. For another example, one field gender. The male and the female looks like not equal and the male record is a majority. If we use this data to create a model, the final model cannot be good because it just presents the result for male. So we need balance operation in data preparation. We need to add more female records in data. It still has some other operation like binning. It does not care about the detail value, but just care about the boundary of this value. For example, we really do not care about the temperature, but just care about cold or hot. So we can bin the temperature to cold and hot. This will transfer one continuous field to one categorical field. It will make some analysis easy. Regression and classification is used to solve the linear issue. With a different target, it can split it to regression and classification. If the target is continuous, it is called regression. If the target is categorical, the algorithm is named with classification. The first one is the frequent pattern meaning. Association rule is a simple and practical analysis technique in frequent patterning, which is to find the correlation between the large number of datasets. And a typical example of correlation analysis is bear and day pairs. Supermarket always put these two kinds of items together. There seems no relationship, but the fact is, the American wife usually asks their husband to buy day pairs for their baby. The husband will buy beer because they like to drink it. When supermarket put them together, the beer will be sold well than before. Clustering algorithm. The simple data is divided into several subsets. They are usually not intersected. Each subset is called a cluster. For clustering algorithm, it is specified as time series here. It is used to analyze a series of data in a continuous time period. provide meaningful insight and predict future value based on previous observed data. So next, let's look at survival analysis. Like the death of a biological organism, the downline of the mechanical system, and the failure of the something else. Spatial temporal is a series of algorithms related to time and space, which usually consist of two concepts: space concepts and time concepts. Spatial data is data that is observed and collected in geography space, and the data itself contains geographic coordinates, such as one example is rainfall in different array of province. Time data refers to a series of observations recorded over time. The data itself contains time attributes, such as rainfall within a month. A spatial temporal data is the data obtained by observation and has the properties of both time and space. For example, some regions are affected by the storm and the rainfall changes with the time. The ensemble method is always talked about because ensemble method is often the best. There is a famous saying that two heads are better than one. Ensemble is a combination of several machine learning algorithms, or a combination of different parameters of an algorithm. For example, random forests are combined a lot of tree algorithms which focus on different aspects, and at last, the different tree will vote for a common result in a majority. Okay, I will introduce you linear engine LE algorithm. LE algorithm covers two parts: linear regression and analysis of variance. Linear regression is used to explore relationship between one continuous target variable and a list of continuous named covariates in algorithm and categorical predictors named effector in algorithm. What's the output of LE algorithm? First, it will output the interaction of different factors. For example, detect interaction of two factors, a covariate or a factor, create square term of each covariate. Second, some calculation of the correlation matrix. For example, compute matrix of weighted crosses products, compute weighted means and weighted number of records. A third one is model selection and regularization. Model selection like best subset forward stepwise. The regularization lasso, ridge, and elastic net. Internal scoring is the first part. It mainly focuses on the prediction results, like predictor and residual values, influences statics, influential outliers. The fifth part is post-estimation. It just includes variance analysis. It is a NOVA. E means a patent of SPSS. It is mainly about marginal mean and other series of subsequent analysis values. Uh, at last, I will introduce you two user cases. The first one is salary analysis. You can look at here. Tony is a data analyst in a company. He wants to analyze the factors to affect the salary of the employees. In order to help HR department building a more reasonable compensation evaluation, he selected SPSS linear engine model for the analysis. Okay, I will show you in DSX with the SPSS linear engine algorithm. This is the basic framework of the DSX. Uh, the first part is some comments for this and the business scenario. I will introduce the data. Firstly, the data includes the following fields: ID, gender, date of birth, education level, employment category, current salary, beginning salary, and months sounds here, previous experience, and minority classification. We can read the data from the API from the Spark. Here you can look like I will read the date frame, and date frame show the first five records. Okay, and the schema of this data. It is a simple data schema for this. So we need enrich method to discover more metadata information for each field from origin data frame. For example, field education is discovered as categorical value through its value is integer type. Look at below. Look at this education 8, 12. That means different education level. After this, I will put it in our linear regression model. We will build a salary as a target, beginning of the salary, and job time, job categorical, gender, education level, and previous experience as a predictor. I will use the default values for the other parameters. Okay, I just think you can also refer to the LE Scala doc for other parameters. Here is set the target salary and other predictor as input field list. After fits, okay, the model is saved in LE model, and the scoring is also very easy. Here I use the orange enriched data as scoring predictor data. After scoring process, look here. This is the prediction target. This is the observed target. Okay, we can look. It is close, but has a distance. Yes, it's last. At last, I will show you the model evaluation. The model accuracy is 86%, and R square is 0.862. It seems the model is well enough, and the model evaluation is basic setting for this. For example, target field is salary, and the model building method is forward stepwise, and other is number of predicted inputs and the number predicted in final model. It is same as 6 because all the predictors are used for in this model, and the AICC is this value. Record summary. There are totally 474. They are all used for the model. This is a very useful information for this model. Predictor importance. Beginning of salary, job category, education level, gender, job time. We can see these five predictors is most important for this model. It means if you have a higher beginning salary or job category is good enough, you will get more salary. Okay. It's as simple as you said, as you see. Next is some save and load operation. It also can be saved as PML or StatML. It's some standard fields for this for algorithm. You can see this fields standard in dmg.org website. Okay, that's all. Okay, next I will show you the second Second user case, overall satisfaction of the customer analysis. Richard is a data scientist in San Francisco International Airport. He wants to analyze the factors to affect the overall satisfaction of the customer. So he wants to build a linear model. Because he is an experienced data scientist and he will use DSX notebook for analysis. Okay, I will show you the DSX at the same time. Okay, this is this one. Oh, this is the second example for LE user case 2. Okay, Richard used so many predictor for his model. First, read the data, use this API, and okay, data frame is here. Show some basic schema for this data. With the enrich operation, data is more detailed. It's one operation of data exploration. Yes, you can see here. Terminal is storage and string. ID is record ID. It's no meaning. Flight and no, gender, you can see female, male. It's easy for us to understand. So as target and input, Richard used all the predictor as the inputs and the target as the overall satisfaction. Yes, he want to find the root cause for this. Look at the model evaluation phenomenon. This model evaluation, model accuracy is 50%. I think it's not good enough. More information is overall target field is overall satisfaction. Model building method is forward stepwise, and he used the number of predictors is 11, but at last the model just used number is 10. The model filter one predictor because the model thinks that field is not useful for this model. Record summary. Okay, the model included 16 records because I think there are some missing value. Yes, using missing value are excluded. So the total number is 1,384. Practice importance. Yes, Richard just want to know what affects the overall satisfaction. Yes, restroom clearness is the most important thing. Yes, I think when you go to toilet, if you find the restroom environment is not clear, people will do not like the terminal airport. Overall cleanliness is the second one. Terminal cleanliness, restaurant purchase, and flight is. You can see this is all the predictor importance, and the restroom cleanliness is the most important. Another is some detailed information for this model parameter, and you can see this. Okay, you can see the observed records is on both on the left and right side of the linear. So I think it can explain the root cause of why the model accuracy is almost 50%. Okay, last thing is some basic statics for this model. Okay, if you are interested in this LE examples, I think you can try it on DSX. If you want to solve some linear problems. Okay, thank you very much. That's all. Thank you.